Hello students, welcome to EduCell. Today's session will start the algorithm. What do you mean by algorithm? We will discuss that one as well as we will discuss the characteristics of an algorithm. Okay, so this is our first video of lecture where we are going to start with algorithm is important in real life or not, as well as algorithm is important for computations or not. That also we'll discuss on this video. And before that, in a day-to-day life, I'll tell you one example which will be very clear about the algorithm and why it is important. You can definitely understand. In a day-to-day life, we have seen many problems. Some problems could be solved, some problems could not be solved. Okay, like the problems which we cannot solve for the timing is, if you can, you know, suppose close your eye for 5 seconds and you are saying you will be on the moon if you open your eyes, that could be a problem. If you want to close your eyes and you think now you are on the earth, when you open your eye you should be on the Mars or might be moon or anywhere. Okay, this is not possible for the timing, but we can take this as a problem for us. So for that, is it needed to write the algorithm? Might be anyone can ask you the question. That time you can tell no solution is there, so no algorithm is there. Then what do you mean by the algorithm? Algorithm is a steps, or you can say a combination of steps or a group of steps which are the part of solution to solve a problem. Or else you can say algorithm is a solution steps only which comprises a solution to a bigger problem, or you can say in other words a simple step. Algorithm is the solution steps helps us to manage effectively the artificial resources like time and space. These are many types of definitions you can say. Okay, so you can say so basically solution steps we are writing. Then in that case you can say solution steps could be said as what? Then the solution steps, if you are writing solution steps as for your problem, that solution step you can say pseudocode. Okay, PSUDO COD. Okay, pseudocode is a false code that you are writing. Why it is named as false code? That also we are going to discuss. False code means we are not actually following any syntax. Then what do you mean by syntax? The syntax are, you can say, the grammars we are using, okay, in our real life languages, like natural languages, which we are actually delivering. In English, you can take an example. There, what exactly happening? Like we are following certain defined or predefined grammars while we are delivering the speech. That time we are actually saying one sentence. Combining each sentence, you can say it's a paragraph or a page where we have written the syntax, or you can say it's a grammar basically we are using. If something is getting changed, it is not considered as the language which we are saying. Like this in the code, if you are following certain syntax, okay, if the syntax is well, then only we can say it's a part of the code or a piece of code. Otherwise you can say it's a false code, it's not a code, not a code, it could be something different. Okay, you can say that one. Then for a real life example, if I'll say where you are actually algorithm in everywhere, in my case, I can say tell you in everywhere you are using algorithm, but to correlate, I can tell you the proper examples of it. The first one, you think, like suppose you are going to take a leave, okay? That time what you are actually doing, you are trying to write an application where it has some certain steps you are writing, which is finite number of steps. There is exactly on a leave there are finite number of steps that you are writing, as well as you are actually supposed to say something which will help you to take or the leave should be granted. Okay, that you are writing in such a way that the leave will be granted. Otherwise, uh, if it is getting failed, so why you are writing an application? So you are writing that applications to get the holiday or might be the leave, okay, for you only. So that is what you are writing, the solution steps. Each lines there is a solution for your problem. Okay. So each lines, which is definitely a finite number of steps that you have written. So this total is your algorithm once it is getting approved. Like through application, you got a leave grant. This is how the application is considered as algorithm. Okay, this is a simple example through which you can understand what is algorithm. Now we switch to the importance of a problem, or might be why problem is needed. Like problem is generated by anyone. Okay, it's we do not know where it generates, but problem is there, so we need to resolve it. Once we need to go for a solution, we are writing certain steps. That steps is algorithm. For a timing, you remember this one. Okay, like to improve efficiency of a computer program, we are writing it. Then what is that efficiency? We will read in other videos, coming of videos. There are lot many videos you'll be getting, like based on the time complexity, space complexity, why does it mean, and why exactly we're using that one. That is based on the efficiency, like to if effectively using of the time and space if there. So definitely you are using the computer programs to improve the efficiency of it. Next is proper utilization of resources. Resources here we are talking about the time and space, which are artificial resources for us. Next is algorithms, like you can say where we have mentioned the impact of algorithm resources. It will be imperative a look at cost, like cost effective. Your cost is not like money you are talking about here. The cost is, you can say, the complexity will be reduced. That is a part of cost we are discussing here. So in general, algorithm we are using to managing two artificial resources like time and space, because space is limited. That if you want to increase that space, you need to pay more. Okay, so to optimize that one, you have to be confident enough within that defined time. Like you have to be very much precise enough. Be like if you are going to purchase the space, that could be enough, like you can invest money. But if you are being limited to use only the 4 GB or 2 GB or 1 GB of space, that you have to go for the effectiveness of the space. Like this, for the time, nobody waits for the answer like 2 days, 3 days. Everyone needs the answer within certain time. If you'll be waiting for the certain time of answers, that should be based on the time. So complexity is a part of, like, it's complexity. The proper definition of complexity is needed to complete a task is complexity. You add time there. Time needed to complete a task is time complexity. If it is more, definitely it is not effective. That's why you are reducing it. And space, if you add space needed to complete a task, space complexity, you need to reduce that one also. So like this, there are importance of algorithm that we studied. Now you can say the steps to write an algorithm. You can say indirectly we are discussing each steps are considered as pseudocode. Also you will be we will be discussing in the next slides of your, like, for this video we will be discussing that pseudocode. So here, the understand the problem with its outcome. First of all, we will understand it. Decide the starting point, where exactly we should start the problem. Also, decide the end point. If we started it, definitely we will end up with some points. So those points we will combine everything. Like after that, we can say the pseudocode is over. That pseudocode is having a solution steps. The whole total is called as algorithm. Like think, determine how each steps will be achieved. That also we will be keep in mind. Then review the algorithm before submitting anywhere. Before saying it's good, well established, whatever that you are saying, before submitting somewhere, you have to review on it, like whether it is really taking the effectiveness of the time and space or not. This is how, like, 5 steps will be comprising of the algorithm while you are writing the algorithm. Okay, so the analyst who is responsible for algorithm is being taking part of this steps while he or she is writing the code, pseudo code. That time they should keep in mind these 5 steps while writing this one. A developer, what he or she has to do, developer, once the pseudocode is given to them, they will code using any of the programming language. A developer and analyst and developer both are different. Analyst is to solve the problem which is being decided by a group of people or might be by a certain organization. Analyst, the part of the analyst which is being done in research and development wings of an organization. So there analysts are being hired to solve the issues. Once it is being done, then developers are there. We will develop it using the language. This is how the program is exactly being running. And research and development we are seeing nowadays. Okay. So next step, these are the characteristics which are more important. Then you can say it is considered as an algorithm or not if certain steps have been written. You should be fixed with the input and output. Next, finiteness. Finiteness means if you have written certain codes, that should be within certain limit. There should be, suppose 10 lines are there, so 10 line must be there. If it is infinite, you cannot read anything because either you can start from the starting point, but you are not ending off with any end point. So infinite number of steps if you are writing means this is not considered as algorithm because you cannot submit anywhere, you are not getting resolution of it. So finiteness means the number of lines should be finite, you can count it. Next, definiteness. Definiteness means each line should be definite for the next line. Suppose you are taking leave by saying your friend's marriage or might be you're attending cousin's marriage. That time what happened? Like the first line said you are actually taking the leave for marriage. Second line you were saying might be for death anniversary of for someone. So death anniversary and marriage are not equal. So each line should be predicting, each line should be depicting one problem. The problem should be uniquely defined. In each step there should be correlation with the same problem. You are saying you are taking leave for marriage, again you are saying in another line, for the death anniversary you are taking leave. No, this is a contradictory or might be it's not correlating. So that's why it's not definite. So every lines of code should be definite, like it will be correlated with the next line, next line will be correlated with the next to next line, like this. Okay. Effectiveness, whether there is effectiveness or not, this is not always playing a vital role. Suppose your algorithm is new algorithm to the world, that time you cannot say because effectiveness will be said if you compare with anyone. Like if there is one person in a class and he or she is might be considered as topper because one member, you cannot compare with anyone, so you can say he is effective or she is effective. But if you compare, like there are more than one members in a class, then only you can say who is the first person. So after comparing, you can say which one is effective or which one is not effective. Based on that, we can decide. So basically, when we are saying effectiveness, that time we are focusing on time and space complexity will be reduced when you are using that one. Might be that it will take less time, means time complexity is reduced somehow. If your algorithm is taking like if there are two algorithms, one algorithm is taking 1 second to complete the task, another algorithm is taking 2 seconds to complete a task. So 1 second is completely taken as the effective algorithm. So comparison must be there. But without the comparison also we can say if these four lines are being a part of characteristics of an pseudocode if you have written, that time you can say yours it is considered as algorithm. But one problem is if it is not effective also, that time you can say it's not an effective algorithm, but it is an algorithm because finite number of steps with the definiteness is there. Okay. And one more thing I will discuss like which is correctness. Correctness. The correctness is all about whether it is correct or not. Whether it is correct or not means the expected output, you can say the expected output must be equal to the current output. Okay. So current output, suppose you can say 10 is even or odd. That 10 is even. Okay. This is your expected output. Suppose you have written a code. Instead of even it is saying odd. That time it is not equal. It is not correct. So your program is giving 10 is odd and you have expected 10 is even. That time even and odd, like expected is not equal to the current output. If such things not happen, so you can say it's not correct. But it might be considered as an algorithm, but it is not your desired algorithm. For getting the desired algorithm, so correctness is important. That part we will be discussing in the next chapter. But before that, you should know why correctness is important. Correctness is important to get the desired algorithm only. Suppose you are finding the code for getting the even numbers. Okay, that time every number which you have expected as even, that should be the current output should be set as even. Otherwise, the conflict will be there. Okay, to reduce that one, we should be focusing on expected output will be equivalent to the current output. Then only we can say it's a desired algorithm. But if it is not meeting with the criteria, you can say it's just an algorithm basically. Okay, but you have to look up all the characteristics whether it is considering or not. The minimum criteria should be input, it has to take output, finiteness, definiteness. Up to this, it has to be following this one. Next one, if effective is good, not an issue. If correct, also good, but correctness should be there where we can say it's a desired algorithm. Okay. Next, pseudocode that we discussed recently. Pseudocode is a false code basically we are writing while to display, like you can say a flowchart could be considered as an algorithm. Okay, like if you are writing in a simple English only to give you the solution, that is part of pseudocode. Okay. Next, the difference I've just kept here. Okay, what is the algorithm? What is pseudocode? You can read it whenever getting time. Like advantage of pseudocode, it will be definitely improving the readability because a layman could understand what exactly you have written. Suppose you are using the regional language to solve it, that is also a part of pseudocode, you can say, because it's a false code you are writing your own, which will be easily understood by the pseudocode, by the layman. The pseudocode should be understood by the layman. That's why algorithm is widely accepted everywhere. Now you can say the how to write the pseudocode. These are the writing style, like we have to arrange the task properly, then only we can have to focus where should we start. Okay, then also you can say what are the conditions that we will apply on this, like it is there in the example. Like we have to appropriate naming conventions we have to use, and also appropriate sentence casing also we have to decide, elaborating everything what exactly been happening, know? So like this, if then like again the conditions if it is needed, everything we have to follow, like how to write the steps, like as usual you are writing the leave applications. All we know, like everything is there is a problem, definitely a solution is there. If solution is there, the solution steps are considered as algorithm and the steps are named as pseudocode simply. So there is a code that I kept for Java code where you can calculate LCM. Okay, for excessively long input values. Here you are trying to find out the input values. So as per this code, you can see, as per this code here the pseudocode is written. So here the pseudocode is not uh, written a well format, because these are, I told you, like this is false code. You can write as for your convenience, like how you understood, how you think like a people will understand. Suppose he or she is unknown to this code, like if anyone will read, how they will react, like yeah, whether they have understood or not. Because a pseudocode we are writing, the main reason of writing algorithm is to give the proper knowledge to a layman, okay, who are unknown to this world. They can understand. That's why we are writing algorithm. It should be easily being understood. That's why the main reason of creating this video is to clearly display the thing, what exactly that, in a traditional way everyone is teaching you the definition, but this is not enough. Definition you can read from anywhere. Why you are coming for this video, the main reason is definitely simpler way is there to understand why we are writing it. If you know why na, then only what could be understood by you. Without why you cannot do anything. You know why, then you know what, then you go for how. Directly, normally we people are directly jump to the how, but how is not to be jumped first. You should know why you are doing it, then you go for what is this, or you may change that one, what is this, then why this is, you can go for it, but how should be the last one, which we people are generally picking on the first one. This is the problem that actually nowadays we are having. Okay, now you can say classifications by implementation methods, recursion and iteration. You will be reading in the next videos, lecture videos. There, recursion means the number of times the function is getting called. Iteration means the loop is getting used. like entry control loop, exit control loop. Entry control loops are like for loop, where from the entry point we will check the conditions. While loop also, okay. While loop also we are using the entry control loop. In the that way we are considering this is entry control loop. And for exit control loop, only do while is there, okay, where when it comes to while, first it will run for one time, but in while condition it has to check the condition. If it is cut, then it will be exit, otherwise it will not be exit. Within that it has to be there, okay. A pointer, the execution pointer will be within the same range. The way of writing the iteration is like this, okay. Loop is getting used in iteration. Recursion, only function is getting called here. Exact and approximation also being there. So sometimes you're getting exact answer like 2, 3, 4. Sometimes you have to take approximation. Suppose you're getting 1.8. That time you can go for approximation. Suppose it could be 2 or it could be 3, it could be 4. Like this, you are just taking the upper value or lower value to make everything clear. Okay. Like serial, parallel or distributed algorithms. Suppose at a time, series wise, if your algorithm is running like one algorithm you have written where input and output, that output of a first algorithm will be used for the second algorithm. Like this, it's a series. And both the way, like we are using, suppose single path, input and output will be given like parallel way, that is considered as parallel algorithms. Distributed, like distributed systems, we are using many algorithms. So that are the part of distributed algorithms. Like distributed applications nowadays we are using to operate a system in a distributed locations, so that algorithms are getting used, okay. So you can say many applications nowadays we are using. Next, classification by design model or design method, which you will be seeing in our next videos, next lecture videos, where greedy method, divide and conquer, dynamic also being discussed, linear programming and reductions, where transform and conquer is there. Okay, so that part is not that much important, but for a basic thing, you should know what greedy method is, what divide and conquer, and what dynamic. So if I'll give you the example, you can think one robot is there. Simple, one robot is there without memory. It has to move from A to suppose B. Here D is a path and E is a path. Okay, through which the greedy will be running. Suppose greedy algorithm. In that case, what it has to be? Suppose there is a robot moving from one end to another. Here these are the distances. Okay, so here these are the distance. In greedy tells you, like, if this is your source means a robot starts its movement and the destination would be at B. Okay, it has to reach to B. There are many paths. Okay, there are you can say like from A to E also a path, A to D is also path. Greedy approach, if you have set only minimum will be picked at the same point, then only what it has to do without memory. This is without memory. Greedy approach is running without memory. Okay, so here what exactly it happens? A robot will start a movement where it checks 1 kilometer and 2 kilometers. So as per greedy, if you have set only minimum will be picked, then only it will reach to A to E, which is 1. Next, there is no other way, so it has to pick this 3, which is 3. Next, it will reach to B. So total distance it is covering is 1 plus 3, which is 4. But 4 is not the correct answer for it, because there is another way also, A to D then D to B, which is giving you 3 kilometers to reach there. But greedy approach will pick the lowest. If you have said no, only lowest will be picked, then only lowest will be picked. But if lowest will be picked, then out of this A, E and A, D, A will be picked, because without memory nahi hai na. So it will fix what are the rules that you are saying. Greedy is faster as compared to other methods, but due to this we are not getting the correct answer or optimal answer. But in this case, if you are using dynamic dynamic programming, in this case, suppose I'm writing DP, it has to use a memory. Okay, Memory, if you can say which type of memory, which type of data structure, I can say it's a 2D matrix or a matrix you are using. Matrix is not a data structure. If you can say it's an array, we are using array, okay, where it is a kind of matrix. If you can take 2D matrix, it is 2 cross 2, 3D 3 cross 3, like 3D matrix will be different, okay. But matrix were indirectly applying matrix, but the meant, if I'm going towards depth, the data structure it is using is array, okay. Memory will be a part of it. Once you have said memory, so definitely we have to first check the possible ways. So A to E and B is 4, A, then A to D, then B, it has to check the possible way it has to cover is 3. Okay, so out of this 4 and 3, we have to save it somewhere in a tabular format or in a matrix format, okay, in an array. So out of this, which one is minimum, that will be picked by the DP. Okay, so definitely DP, the probability is 1 in case of DP. Okay, like dynamic programming will give you the correct answer, the probability is 1, but memory is there, it will take less time, it will take more time as compared to the greedy approach. Okay, divide and conquer is what then? Divide and conquer, if you can say, we know we are having food on a regular basis. You can think of a pizza. Pizza, one slice that I'm saying, there are 4 slices, 6 slices, like this. There are many slices in a pizza. Okay. So suppose one slice, if you're taking, to have it, that time what happens? You cannot take at a time because your mouth is smaller than the food which you have right now. So you have to again divide that. Okay, once you have divided from each chunks, again you have to divide from each slice, you have to divide each chunk as per your mouth, the mouth that you can chewing. Okay, so you have to divide. The problem is, a big problem is the pizza, you have to have it. Okay, you have to just for lunch or might be dinner or might be breakfast you are going. So that time a bigger problem is the pizza, is a personal or might be medium or whatever, large, whatever. Okay, that time you are picking one slice, again the slice is also larger than your mouth, you have to divide it again. The problem is divide until you can absorb it. Okay, this is what a divide. Then conquer means when you are swinging. Okay, that part I'm just elaborating here. That part, okay, which you have cut or divided, that will be chewing by you until it will be a smaller piece to get into the stomach. Okay, so this part until the chewing to smaller parts, this is what a conquer is. Okay, because you are chewing, this is conquer. Up to this you have to actually divide it. Suppose this is a pizza, 4 slices. Up to this we actually are dividing this one. Okay, the pizza, we are dividing the pizza to up to this, so it's a part of dividing it. Okay, divide, then conquer. After this it will store in a stomach. Okay, when it is storing in stomach, this is combine. Like whenever you are saying divide and conquer, there are 3 procedures are being taken care of. One is first we have to divide it, then we have to conquer it. Once we chewing it, we have to store it in a stomach. This is how it will run. Divide, first we divide it, next we conquer, next we combine. Okay, combination, why combination is needed? Because we need to store all the data in a sorted format. You will read in merge sort, quick sort, like these are the sorting techniques which are basically using the divide and conquer approach. You will be reading that one in future lecture videos. Before that we should know why it is very important. And one more thing, if I can say, if you have seen all the videos, so greedy and sorry, dynamic and divide and conquer, the main reason is overlapping sub problems. Like one problem is suppose solved, so that could not be solved in a dynamic, but divide and conquer, it has to solve whether the similar sub problems you are solving. So overlapping sub problem could be solved using dynamic, but overlapping sub problem is not there in divide and conquer. This is how we have classified the in design method, and other classifications are also there. a randomized algorithm through random inputs. We can random choices. We can go for the algorithm. Like immediately, it could be giving you somehow might be lesser time complexity. It has to take, like for example, you can say randomized quick sort is also part of it, where we can expect lesser time for the getting it sorted. Classification by complexity is also like, if you have suppose linear time, might be if you are going with a logarithmic time, that could be classification by complexity. It might be taken on a space or time. Research area also, like machine learning, all the type of, like research algorithm, you can say uh, machine learning, artificial intelligence, all types of algorithms based on the research areas are being classified. Next, branch and bound enumeration and bracketing is a part of it, where we are basically using an artificial intelligence. uh, Most of, like are getting used in artificial intelligence because machine is getting trained, so we are using it to make the machine is getting artificially intelligent. So these are the way which we discussed in a broader way. Upcoming videos we will be discussing like how we can compile each problem in our own way. Okay, and I hope you understood this one. Thank you for watching the video. Have a good day.